Hello everybody, welcome to another video lesson. Today we are doing something very special. We are going to combine your newfound knowledge of trig functions with graphing. You guessed it, we are going to graph sine, cosine, and tangent functions today. So let's hop right into our concepts, okay? Here I have a graph of sine, okay? So if we're looking at sine and cosine graphs, those are actually our parent functions. Y equals sine theta and cosine equals sine theta. Okay, those are kind of the simplest of the sine and cosines as far as we can go as far as graphing, right? So we have a few parts of the graph that I want you guys to know and understand. The first one being the midline, okay? The midline in this lesson is going to be just our x-axis, okay? The midline is this horizontal line at which we are oscillating, okay? We're going up and down from this midline here, all right? And in a lot of cases, especially in this video, that is going to be the x-axis. Okay, not always, but it will be in this video. Now our amplitude is another part that we need to know here. This is going to be our peak, okay? So this is the furthest distance, okay? And notice I said distance, so I'm talking positive value. My amplitude is always positive. Okay, so it's the furthest distance from the midline to that peak. So we can look at the amplitude here going from our midline down, but that's the exact same value, right? It's just a distance that we're looking at, so it doesn't matter. It is not a negative value. It's just a positive value, whatever that distance is, okay? So again, our midline is our horizontal center line that we are moving up and down from, that we're oscillating from. And then our amplitude is our max distance from the midline, okay? Now our period is, we've seen this before, that's our horizontal line that where we start to see some repeat values on our function. Okay? And we can find our period with the equation. The period is equal to 2 pi over the absolute value of b, or this should be just 360, not 180 here. Get rid of that. Okay, or 360 degrees divided by the absolute value of b. You're probably wondering what b is. I'll throw up frequency here before we talk about B here. Okay, B is our change. B is what we find in our change in period. Okay, so if I have y is equal to a sine b theta and y is equal to a cosine b theta, that gives us changes in both amplitude and period. Okay, now our change in amplitude comes from this value here, a. Okay, that a is how we find our amplitude. Whatever that value is, a is our amplitude. Now, b here is what affects our period, all right? So if I have y equals cosine 2 theta, then to find the period value, I would say 2 pi over 2, since my b in that case was 2. And that would simplify to just pi. So my period length would be pi, okay? So that is our period. Now frequency is what we'll find in real world applications. That is just the number of cycles per period of time. So oftentimes it's helpful to understand how many cycles we go through or how many periods in a given length of time. And we would define that as the frequency of our function, all right? Now this function looks pretty weird. We're going up and down, right? So what is this actually showing us? What is this graph showing us? Well, let's take a look at what this really means here. If I have, say, the sine function here, I've got sine of theta, and I've got this unit circle here also. Okay? So the sine theta, y equals sine theta, the graph of that is just measuring what is our y, right? Our y is our sine on a unit circle, okay? So since our y coordinate is our sine, that is just what we're graphing as we go. So let me go ahead and play this video for you. Okay, the red line that we have here is our sine of graph. And what we're getting, how we're getting these sine functions or these y values on this red graph is just this distance here, this value that is our sine coordinate on our unit circle. So see, as it gets closer and closer to 0, now my graph gets closer and closer to 0. Okay, and as we were reaching our maximum and minimum values, that's when we were reaching our angle being pi over 2, right? Which is where our sine value is 1 or -1. As we can see here, we're at 1 and -1 in those cases. Okay, so if that makes sense, hopefully it does. If not, go ahead and rewatch that part of the video and really see what we are graphing when we're graphing our sine and cosine functions. Now, let's take a look at our tangent graphs here. So our parent function is going to be y equals tangent theta. Now, for our tangent graphs, we do have a bunch of vertical asymptotes. All right, now those vertical asymptotes are going to help us define our period, and we also have our midline. Okay, our midline, again, in this video is going to be the x-axis, but that is just the line that we are oscillating from again, which we've seen before. Our period now for our tangent is going to be a little bit different. Our period definition doesn't change. However, if I have changes to our asymptote period, y is equal to a tangent b theta. Now my period, instead of 2 pi over b, or absolute value of b, or 360 degrees over absolute value of b, now we just have pi over b and 180 over b. Okay, so that is our period length for our tangent functions. So now our vertical asymptotes are going to be in between where our function intersects our midline. So notice here I have a midline intersect here at 0. I also have one here at pi. So I would have a vertical asymptote in between there at pi over 2. Likewise, when I go this way, I have another midline intercept at negative pi and one here at 0. So I'm going to have a vertical asymptote right in between there at negative pi over 2. So my period of just tangent theta would be pi. So another way I can think of this is if I start at the origin, okay, my tangent function starts at the origin. Now I can go half of my period one direction and half of the period the other direction in the negative y direction, or negative x direction, sorry, or negative theta direction, I guess. And that would be one period right there. And from there, you can just repeat that, and you're going to have this repeating graph that looks like this. So you'll have your vertical asymptotes at every midpoint between these midline intersections. Hey, so that is it for our concept, guys. That is really what we're looking at with our sine, cosine, and tangent graphs. So let's go ahead and do some examples. Example 1, simpler, we're just going to find the amplitude and period of our functions that we're looking at. Okay, amplitude and period. So I've got y is equal to cosine 1/2 theta. Now, if I look at our sort of generic form of this, this is y equals a cosine b theta, right? So in this instance, a is equal to 1 and b is equal to 1/2. Now, a I know is my amplitude always, or really the absolute value of a. So my amplitude is equal to 1 in this case. Now to find my period, that's going to be 2 pi over absolute value of b, or 360 degrees over the absolute value of b. So in this case, I'm going to use 2 pi, because we need to be able to work really in radians and degrees. So I'll have 2 pi over 1/2, since my b is equal to 1/2. So that's going to be the same thing as 2 pi times 2 over 1, which is going to give me a period length of 4 pi. So you guys go ahead and pause the video and find the amplitude and period of this function here. Okay, hopefully you got the amplitude was 3 and our period was 2 pi over 5, or if you did it in degrees, our degrees period would be 72 degrees. All right, now let's take a look at an example of graphing, okay? We're going to do this the long way and then we'll do a shortcut way. Okay, so if you're ever going to graph a function, one way you can do it, if you're not really sure what it's going to look like, just go ahead and make a table. Okay, go from 0 to 360 or 0 to 2 pi. Plug in those values here. So all I'm doing here is whatever theta I chose. So I chose 0 to 360 degrees. I just plug this in to this function here for theta. Plug that in right there. So I would have 1/2 sine 2 times 0, and that's going to give me 0. And then I plugged in 1/2 times sine 2 times 30 degrees, and that gives me 0.43, and so on and so on and so on. All right, and then you just go ahead and graph these points one by one. So I have 0, 0, 30 degrees, 0.43. It is worth mentioning here that my x-axis here is degrees. This is my angle theta. Horizontal axis is theta here, and our vertical axis is y. So we're just going to go ahead and keep plotting our points. So I've got 45 degrees, 0.5. I've got 60 degrees, 0.43, 90 degrees, 0, and so on. I just keep graphing each one of these points, okay? Graph them, graph them, and then you can go ahead and connect the points, and you have your graph. Notice here I have an amplitude of what? 1/2. What is the maximum value at my peaks? 0.5 right here, 1/2, right? So when I go up, when I'm positive, the highest I can get is that whatever my amplitude is, in this case 1/2, and when I go down into the negatives, the lowest I get, the furthest away from my horizontal axis or my midline, again is 1/2. So let's go ahead and do this a quicker way. Okay, I have the same function here, and we're going to just graph it in a quicker way. So first thing I need to do when I'm doing this faster way, I'm going to find my period. So I have a b value of 2, which means 360 divided by 2 is going to be 180 degrees. Now my amplitude, we already said, was 1/2. So I'm going to just plot, since I know that sine starts at 0, okay, starts at 0, and the period length is normally 360. In this case, it's going to be 180. So I just need to put an x-intercept, or a midline intercept rather, at every 180 degrees. Okay, every 180 degrees, I'm going to put an x-intercept or horizontal midline intercept. Now, halfway between that, because this is an entire period length right here, right? From this first red plot point to this coordinate point. This is a full period, but I know that sine goes up and then it comes down and it crosses that midline before it comes back up to start a new period. So that point where we are crossing the midline again is right in between the endpoints of my period. So at those endpoints, guys, we are going to put another point here. Okay, so I've got period points at 0 and 180 and then 360. And then I've got these kind of midway points here at 90 degrees and 270. That is where we are, again, crossing our midline. Now, where are we finding maximum points, maximum peaks, right, on this graph? Well, again, that's just going to be midway between each one of these points. So starting here at 0, in between 0 and 90 is going to be 45. So I know I have a peak there at 45. And then in between 90 and 180 is going to be right about there. So I'm going to then have a peak, but I know it's going to go up and then dip below. So that peak is going to be a negative value. And then again, I can just repeat that for however many periods I'm graphing. I'm going to suggest that you guys always graph at least 2 periods, okay? I'm going to require that. Always graphing at least 2 periods for these graphs. And guys, that is it. Once I have these critical points here, I can just go ahead and connect these because I know what the general shape of sine will look like, and I have my graph already. All right, let's look now at tangent graph. Okay, we are going to find the period of and graph y is equal to 3 tangent 1.5 theta. So first things first, let's go ahead and find the period. Our period of tangent is going to be 180 degrees divided by absolute value of b. So that's going to be 120 degrees because our b is 1.5. Now, we know that tangent always starts at 0, right? Because tangent would be sine over cosine, right? And when theta is 0, my sine is 0 and my cosine is 1. So I have 0 over 1. So I'm starting here at the origin every time for tangent. Now, again, I'm going to put a midline intersect at each period length duration. So every 120 degrees, I'm going to put a midline intercept here. So that's going to look something like this. So I've got 0, 120, 240. I've got 0, negative 120, negative 240. So every 120 degrees, we are going to have a midline intersection. All right. Now, halfway between those, instead of having a maximum point, we are actually going to have vertical asymptotes. You're going to have vertical asymptotes here. So at each one of my halfway points in between each one of these midline intersects, we are going to put a vertical asymptote. Okay. Now from here, we can just make a very small table. Let's go ahead and find 2 values on each side of our origin. So we're going to say we're going to look at 20 and 40 and negative 20 and negative 40. And that's going to give us these points right here. And we can go ahead then and plot out the rest of that graph. Now, once I have this, guys, we are just going to copy this exact graph into each one of these period intervals. Because I know that this is a repeating function, right? We are just going to copy this into each interval like so. So that is it, guys. That is graphing sine, cosine, and tangent. Hopefully the shortcut way makes sense. That'll save you a whole bunch of time, and good luck with your practice.